Today we're going to look at getting ready for our Chapter 7a test. Our first questions say to decide whether or not the listed function represents exponential growth or decay. Give the percent of growth or decay. For example, you could say 42% growth. And then also identify the y-intercept. So we are looking at a formula y equals a times b to the x power. Our b value is often referred to as 1 plus r, some kind of rate of increase or decrease. So what we're doing when we try to determine if it's growth or decay, we look at this piece that's being raised to the power. So our 0.7 in this case. And we're saying 1 plus something gave us 0.7. If we subtract 1 from both sides, we have r being 0.7 minus 1, or negative 0.3. That means we are going down 0.3. All right, so this is a decay situation. We are losing 30%. Okay, so I'm not going to say negative 30%. I'm going to say we have a 30% decay. All right, that indicates that it's going down by that. Our next example. Whoops, sorry, forgot the y-intercept. When we look at our exponential function, our a value here is going to be our y-intercept. And that's because if we plug a 0 in for x, b to the 0 is just a 1, and 1 times a is always going to get you a. So our y-intercept in this case, we put a 0 in for x, and our a value is 5. All right, for our next one, we have y, or f of x, equals 0.4 times 1.45 to the x power. So again, we're looking at 1.45. So 1 plus what gave us 1.45? Subtracting 1 from both sides, we have r being 0.45. Since it's coming out as a positive value, we have a growth situation. We would say we have 45% growth. And again, looking for that y-intercept, our a value is 0.4, so my y-intercept would be 0.4. Now, the third one, it's a little hard to tell, but this is a negative x for a power. We have 14 times 5 to the negative x. Because of that negative, we're going to have to flip that base. So I want you to think of this as 14 times 1/5 to a positive x power. Now it's in the format where we can identify if it's growth or decay. So really watch for those negative powers. We are going to have to flip them. All right, looking inside, we are saying 1 plus something gives us 1/5. If we subtract 1 from both sides, 1/5 minus 1, or 5/5, 1/5 minus 5/5 would give us negative 4/5. And because it's a negative, we are decaying. 4/5 is the same as 0.8. So we have an 80% decay. All right, and then looking at our y-intercept again, our a value is 14, so we are intercepting the y-axis at the point 014. All right, then we started looking at graphs of exponential functions. It says, describe how the graph of each function is related to the graph of its parent function. Then graph it. You are expected to show the parent function graph and then shift it appropriately. You are also going to be asked to list the domain, range, and write an equation for the asymptote. All right, so for our parent function, our base is 3. Our parent function is just y equals b to the x. So we are going to look at y equals 3 to the x power. We're going to plug in numbers from -2 up to +2. 3 to the -2 power means we have to flip it over and square it. We get 1/9. 3 to the -1, we just have to flip it over, so 1/3. 3 to the 0 is 1. 3 to the first is 3, and 3 squared is 9. So on my graph, I expect you to put the parent function points. So -2, 1/9, -1, 1/3, 0, 1, 1, 3, and 2, 9. Okay? All right. The types of transformations that we are doing. The negative in front means we are reflecting over the x-axis. And the 3 on the end means we have to move it up 3. So we're going to take those values, we're going to reflect them over the x-axis, and then shift them up 3. So I'm going to start with this top point here. It's up at a 9. When I reflect it over the x-axis, I'm at -9, and then I have to move it up 3. So it's going to land there. Okay? My next point, I'm going to do the point 1, 3. Reflecting it over puts me down here at -3, and then I'm going to move it up 3, so I end up at 0. All right? The next point, 0, 1. Reflecting it over puts me at -1, and then moving it up 3, I'm up here at 2. The point -1, 1/3. Reflecting it over puts me at -1/3. When I move it up 3, I am just below the -3 line. And the same thing's going to happen with that 1/9 when I flip that over. My board's off just a little bit here. All right. When we do vertical translations, like moving up 3, that means the asymptote also moves up 3. So instead of it being here on the x-axis, I'm actually up here at 3. So my graph should be coming up from here and leveling off just underneath that asymptote. All right. Our domain for our picture here, we have x being all reals. My range, all of my y values, they're starting down here, and then they're leveling off right under that 3 mark. So my y values have to be underneath 3. And the asymptote, the red dotted line, would have the equation y equals 3. All right, our next example, y equals 8 times 1/2 to the x power minus 5. The 8 in front is going to be a vertical stretch by a factor of 8. That means my y values will all get multiplied by 8. The minus 5 at the end means I have to move the whole thing down 5. So my parent function, y equals 1/2 to the x power. My t-chart on my test is going to be based on the parent function. So -2, -1, 0, 1, and 2. 1/2 to the -2 power means I have to flip it over and square it, so I end up with 4. 1/2 to the -1 means I flip it over and it's a 2. Anything to the 0 power is 1. 1/2 to the first power is 1/2, and 1/2 squared is 1/4. So I'm going to graph those on my picture here. -2, 4. -1, 2. 0, 1. 1, 1/2. And 2, 1/4. So we're getting closer and closer. It's a decay situation, getting closer and closer to the x-axis. To do my transformation, I'm going to take my y values and I'm going to multiply them by 8. And then I have to move them down 5. Well, if I take 4, multiply it by 8, I'm at 32. Moving down 5, I'm still up at 27. So that's going to be off my graph, but that's okay. I have enough other points that I can use. If I take this 2, multiply it by 8, it's 16. Moving it down 5 puts me at 11. So I'm right above that next tick mark. If I take the point 0, 1, multiply that by 8, I'm at 8. Moving it down 5, I am at 3. 1/2 times 8 is 4. Moving down 5 puts me at -1. The 1/4, multiplying it by 8, gets me a 2. Subtracting the 5 puts me down 3. All right, looks like my dots are just off by 1 here, I'm noticing. Let me fix that. All right, so we were at the 1 multiplying it by 8 was 8, moving down 5 was 3. The 1/2 multiplying gets us a 4, moving down 3 puts me at -1. And then the 1/4 times 8 is 2, moving it down 5 puts me at -3. All right, now the asymptote was here on the x-axis. But we said everything had to get moved down 5. So my asymptote is going to be down here at 5. So my graph is going to come down and level off just above that. All right, so for domain, we have x can be all real numbers. My range, all my y values now are above that green dotted line at -5, so I have y has to be greater than -5, and the asymptote is at -5, so y equals -5. All right, our last graph. Our parent function is just y equals 3 to the x. We did this t-chart on the first graph, so I'm going to go through this very quickly. -2 would put us at 1/9. Then 1/3, 1, 3, and 9. So let's get our parent function points plotted. Again, my graph is just a little off here. All right. Then our transformation. The 2 here is going to move it right 2, and the -1 is going to move it down 1. So I'm going to take all my points, I'm going to shift them 2 to the right and down 1. So I end up here, 2 to the right, down 1, 2 to the right, down 1, 2 to the right, down 1, and 2 to the right, down 1. The asymptote again is going to shift. We're going to move that down 1 as well, so we have a horizontal line here at -1. That is my asymptote, my graph, and I want you to be very particular on your test. You need to show that it is coming down and leveling off just above that line. Okay? Your domain is always all reals. Your range in this case, our y values are leveling off right here above -1, so y's have to be greater than -1. All right, shifting to our exponential equations. Notice the directions. You have to write a model to model the situation before you try to solve it. So I'm going to be looking for 2 separate equations, one that you set up the model and then one where you use it to solve it. First example says the kangaroo's population in Australia are said to be decreasing at a rate of 2.4% per year. Researchers this year found 14,000 in the wild. How many kangaroos will there be in 5 years? So again, when we write our model, we're going to ignore this for a minute. All right, it is a decay situation. I know that because they said we are decreasing. So I'm going to start out y equals total number to start with. We had 14,000 kangaroos, but we are losing, so we have to decrease it by 2.4%. 2.4% means my R value is going to be 0.024. I have to change that percent into a decimal. And then I'm raising it to some unknown power. Okay? In this case, we have our model now. We're going to use it to solve. So if I know that I have 5 years to do this, y would equal 14,000 times 1 minus 0.024 to the 5th power. Go ahead and grab your calculators. We are finding the number of kangaroos, so we would round to a whole number, and we should end up with 12,399 kangaroos. All right, our next one. It says house values are on the rise. Your family invests in a $120,000 house because the realtor says houses in the neighborhood are increasing in value at a rate of 4.5% per year. How much will your house be worth if you want to sell it in 4 years? Okay, so again, we are going to hold off on this for a minute. We know our investment was $120,000. We know we are increasing, so it's a growth situation, by 4.5% each year. So the total value, I'm going to use a V for value, the total value, we have $120,000. It is growing, so we have 1 plus. Now our R value, if we have 4.5%, converting that to a decimal would be 0.045 to some unknown time. Okay, that can be my model. T is time, V is value. And then to solve it, I'm going to plug in the 4 years. So I have 120,000 times 1, and I can add 1 plus 0.045 and just write 1.045 to the 4th power. The total value of that house would be $143,102.23 after 4 years. Question 9. Your starting wage at work is $8 per hour. Your boss says you will receive a 6% bonus each year. 6% bonus means our money's going up, so we have a growth situation. When will you make over $10 per hour? Again, we're going to hold off on answering that till we write our model. So our wage, we use a W for wage. We start with $8. We are gaining 6%, a 6% raise over T years. Okay? Now, the question says, when will you make over $10? So we're looking for our wage here to be 10. So our power is unknown, and at this point we don't have a way of solving for a power. We will learn that in the second half of our chapter. But for now, we are going to graph. We're going to set y sub 1 equal to 10, and we're going to set y sub 2 equal to the other side, 8 times 1.06 to the x power. Another option would be to divide out the 8 first, and if you want to do it that way, you certainly can. All right, so since I've set my equations like this, for my window, I'm going to go from 0 to probably, let's get rid of this here. Let's go from 0 to probably about a 15 or a 12, just so we get past that 10 mark. And I'm going to leave this from 0 to 10. So when you graph it, you should see an exponential curve, and you're looking for that line coming across at 10. And we're trying to find that point of intersection. To do that, we're going to do second trace on our calculator, and we're going to choose intersect. And the value we get for that is 3.829. Now, it says we get the bonus at the end of each year, so we need to round that up. It's going to take us 4 years to be making at least $10. For question 10, it says, from birth, your parents set up a bank account to help save money for your first car. They put in $4,000 and are getting a 5% interest rate compounded quarterly. How much money will be in the account when you're 16 and you can buy your first car. All right, since it says compounding quarterly, we have to go to that compounding formula. A equals P times 1 plus R divided by N to the N times T power. All right, plugging in what we know. We start with $4,000. Our interest rate is 5% as a decimal, 0.05. It's being compounded quarterly, which means N is 4. And we're looking for an unknown time. So again, this is my model. Now I want to know when I'm 16. So 16 years later, how much am I going to have? So I have A equals 4,000 times 1 plus 0.05 divided by 4 to the power 4 times 16. And remember, some of you may need to put your power in parentheses for this to work out right. Our total amount, $8,858.13. So they invested $4,000, and now we can buy a car worth almost $9,000. All right, our last question. You put $1,500 into an account, earning 2.5% interest compounded continuously. Find the amount in the account at the end of 7 years. So the word continuous there, or the phrase compound continuously, means I have to use my Pert formula. We are looking for the total amount. We know that we are starting, our principal is $1,500. Our interest rate is 2.5%, so 0.025 for T number of years. Okay, that's our model. To solve it, we are going to put 7 in for T. So on our calculators, 1,500 times e to the 0.025 times 7, and our total value is $1,786.87. All right, your homework is going to be a worksheet that I will pass out to you now.